Hello my dear students. So we are continuing with the same lesson, and in this lesson I am going to start a new topic where we discuss gases, their preparation, properties and uses. So in this lesson from the beginning we discuss what chemical and physical changes are, then under chemical changes the chemical reactions, how they occur, the 4 different types of chemical reactions, balancing chemical reactions. All those are what we discuss. Then thereafter we discuss the reactivity of metals with different substances. Then the activity series, uses of activity series, and in the previous chapter I discussed the extraction of iron from its iron ore as well as extraction of gold. So now this is a new topic where we discuss the gases. 3 different gases, hydrogen, oxygen and carbon dioxide. We will see how we can prepare those gases in the laboratory, then the properties of those gases as well as how we use them in our day-to-day life. So gases, their preparation, properties and uses. Under that, the first gas is hydrogen. So if you take the atmosphere, students, you all know the atmospheric air. Normally there is 78% of nitrogen, 20% of oxygen, there is a very small amount 0.03% of carbon dioxide, and there are some noble gases. But we don't get hydrogen in very significant percentage. It's actually present in a very small percentage in atmospheric air. So in the atmosphere, hydrogen occurs in a very small percentage. It is the lightest gas. So it occurs in a very small percentage in atmosphere, and also it is the lightest gas. Why do we say lightest gas? Now if we take hydrogen, if we write the chemical formula, it is H2. It is a diatomic molecule, and you all know hydrogen is the simplest atom that has only one proton and one electron. You are familiar with the isotopes of hydrogen, protium, deuterium, tritium, but still their mass is very less. So if you can remember, the relative atomic mass of hydrogen is 1. So when there are 2 atoms of hydrogen in one hydrogen molecule, that is H2 molecule, the relative molecular mass of hydrogen is 2. And therefore, the density is also very less. So this is the lightest gas. Then if we look at the physical and chemical properties of hydrogen gas, you can see here, students, I have listed out some of the topics. I will explain each property. The first one is density. So we already said it is the lightest gas. So it has less density than that of air. So hydrogen has less than that of air. So density of hydrogen is less than that of air. So normally when there is air and hydrogen, air will go down, hydrogen will go up. You are familiar with this example or this observation. We have balloons filled with hydrogen gas, and normally those balloons usually tend to go up. We use those for decoration purposes. When you tie those hydrogen balloons with a ribbon and attach it to a surface, always the hydrogen balloons go up. That is because the density is less than that of air. Then if we look at its relative molecular mass, I already told you all H2 molecule, relative molecular mass is 2. Relative molecular mass does not have a unit because it's a relative value. Then if we consider combustion, now you are familiar with this also, students. Normally hydrogen is used as a fuel in rockets. How is that possible? Because it can burn. So it is a combustible gas. Hydrogen can burn in air. So it is a combustible gas. Combustible gas. Then solubility in water. Now if you take the H2 molecule, it is slightly soluble in water. That is, hydrogen gas is slightly soluble soluble in water. And it is a colorless gas and also an odorless gas. So these are the physical and chemical properties. Mostly physical properties, the density is less than that of air, then the relative molecular mass is 2. But combustion, it is a combustible gas, that is of course a chemical property. It is slightly soluble in water, it is colorless, and the gas is odorless. So those are the properties. Now I will move on to the next slide where we discuss the preparation of hydrogen gas. So here, in the laboratory, hydrogen gas can be prepared by reacting a metal such as zinc or magnesium with an acid such as dilute hydrochloric acid or dilute sulfuric acid. So you are familiar with these types of reactions, students. Metals react with dilute acids, forming the salt and liberating hydrogen gas. So the products are the salt of the metal and hydrogen gas. And you all know what type of reactions these are. Single displacement reaction. So the common metals are zinc and magnesium, and the common acids that are used are hydrochloric acid and dilute sulfuric acid. You should know to write the reactions between these metals and the acids. So if we take zinc and dilute hydrochloric acid, the products are going to be zinc chloride, ZnCl2 plus H2 gas. So to balance the equation, we need to have 2 hydrochloric acid. So Zn plus 2HCl giving rise to ZnCl2 plus H2 gas. The same way, if we write the reaction with magnesium plus HCl gives rise to MgCl2, that is magnesium chloride, and H2 gas. Here also, to balance the equation, we need to put a 2 there. Mg plus 2HCl gives rise to MgCl2 plus H2 gas. The same way, metals can react with sulfuric acid. So these two, HCl is hydrochloric acid, similar to that with sulfuric acid. So if we write the reaction of zinc with sulfuric acid, H2SO4, you will get zinc sulfate. Now zinc has valency 2, sulfate also SO4 2 minus, so zinc sulfate is ZnSO4. You are familiar with that chemical formula. Then we get H2 gas. Now look at this reaction. We need to balance that. Do we need to balance that? Zinc H2SO4 gives rise to zinc sulfate plus H2. It's already balanced. So no need to balance it. The same way, if we take magnesium and dilute sulfuric acid. Dilute sulfuric acid, you will get magnesium sulfate, MgSO4 and H2 gas. So here also the reaction is already balanced. Mg plus H2SO4 giving rise to MgSO4 plus H2. So in all these, hydrogen is displaced by the metal. And you all can remember in the activity series, both magnesium and zinc, they are above hydrogen in the activity series. So because of that, they are able to displace hydrogen. And the salt and hydrogen gas are formed. So here, if we write the common reaction, metal plus dilute acid gives rise to the salt of metal and hydrogen gas. And these are single displacement reaction. Single displacement reaction. So these are knowledge that you already have from the previous discussions. You need to relate them here as well. I have told you all, always you need the balanced chemical equation and you should know to identify what type of reactions these are. So those are the reactions that can be used to prepare hydrogen gas in the laboratory. So we will use one of those methods to prepare hydrogen gas. And remember students, all these are dilute acids. We use a dilute acid and a metal. So let's move to the next slide. Activity: collecting hydrogen gas in the laboratory. And the required materials are shown to you. So here this is dilute hydrochloric acid. Dilute hydrochloric acid. So here you can see dilute hydrochloric acid. Then we need to have some glass tubes. Then here we need to have boiling tubes. And we need to have rubber tubes. Rubber tube. Then on this side, we need to have zinc granules. We need a conical flask. Then we need a thistle funnel. Now a funnel like this with a small funnel container and a long stem like this, that is known as a thistle funnel. I am sure you are familiar with all these glasswares. Then we need a trough with water. Trough with water. Dry equal. Equal is what you get from the coconut leaves, the veins of the coconut leaves, the parallel veins. So that can be dried and taken as the dry equal. And also we need a matchbox. So those are the materials that we need: dilute hydrochloric acid, boiling tube, zinc granules, conical flask, thistle funnel, glass tube, or glass tubes actually they have to be connected together. Then we need the rubber tube, trough with water, dry equal, matchbox, and also usually these glass tubes are usually used as the delivery tubes. So here they are used as the delivery tubes. And in addition to that, when we prepare gases, we need something called the beehive shelf. Beehive shelf. Beehive shelf. Beehive shelf, this is a structure like these students. It's a cylinder, a square, circular shaped thing like a small cube. You would have seen this in the lab also. There is an opening there. This is usually either made up of metal or a ceramic porcelain structure, and apparatus available in the lab. And here you can see it is like this, some small stage, a beehive stage or beehive shelf, an opening at the top, and also there is like an opening here. So when we make the setup, when we connect all these materials and prepare the setup or the apparatus to collect hydrogen gas, I will explain the function of a beehive shelf. So in addition to all these, we need this beehive shelf as well. So with that, I will move on to the next slide where I explain the diagram of the apparatus used to collect hydrogen gas. So method. Now here you can see everything is connected together. I will label them starting from this side first. So this top one is the thistle funnel. Then here we have the delivery tube, or it is actually the glass tube. Then we have the rubber tube there. I will label everything and then explain the apparatus. Then here we have the hydrogen gas collected. We have the gas jar that is also needed. Then here we have the beehive shelf, a trough, and there is water. Then here we have the zinc granules, and on this side we have dilute hydrochloric acid, that is this. Then we have the conical flask, and we have the rubber stopper, or it can be cork also. So this can be either a rubber stopper or a cork. Anything is fine. A rubber stopper or cork. So these are the parts of the apparatus used to collect hydrogen gas, students. Here you can see we take the conical flask. Into that we take the zinc granules. So those are tiny pieces of the zinc metal. They can react quickly with dilute hydrochloric acid. We need to have the thistle funnel like this, and you have to remember, students, the thistle funnel has to be, it is long, and it has to be connected in such a way that it comes directly up to these zinc granules. So when you pour the dilute hydrochloric acid through the thistle funnel, it comes and falls on the zinc granules. The splashing is reduced, and also immediately it starts to react. So that is why we have to have the thistle funnel long. That's very important. But then you see this delivery tube or the glass tube that has to be above this acid level, so that when the acid reacts with the zinc granules, the gases are evolved up. And as we told, or as we discussed, hydrogen is less dense than air. So what will happen? It will always move upwards. It will enter into this delivery tube, and through this it will be delivered through the rubber tube. So here we use a rubber tube so that it is flexible. And here, this is the beehive shelf. So like I showed you all, there is a hole. It is an opening like a circular opening or a half circular opening on the side. Through that we can send this delivery tube, the rubber tube. So it's easy. Then what happens is we have the trough with water. We place the beehive shelf there, and we have to fill this gas jar with water, completely with water. Right? Initially, it has to be filled completely with water. We have to invert it so that no gas bubbles enter into it. So it has to be completely filled with water. Then the rubber tube is passed into this. We place the gas jar on top of the beehive shelf. I showed you all in the diagram. There is an opening on the top as well. So the gas jar is above that. So what happens is when zinc granules and dilute hydrochloric acids react, hydrogen is produced that travels through the glass tube, that is the delivery tube, then through the rubber tube, through the hole into the beehive shelf, and from there through the circular opening it enters into the gas jar. And since hydrogen is less dense than air, it is also less dense than water. So what will happen? Hydrogen will go up, water will be pushed downwards. So there the water is displaced by hydrogen gas and it is displaced downwards. Because of that, we call this method as downward displacement of water. So, we can collect hydrogen using the downward displacement of water. That is one method that can be used. So, here there are a few things that you all need to remember, students. In addition to this setup, if you are given the diagram, you should be able to identify all the parts and also you should know some of these practical considerations. I will write them down here. It's easy with the diagram. So, one point, the thistle funnel has to reach up to the zinc granules. At the same time, the glass delivery tube is attached at a higher position or level. So, this is what I said. Thistle funnel has to come down, the delivery tube has to be up. You all have to remember that. So, when we have this beehive shelf, students, you have to remember now if we don't have the beehive shelf, if we pass the rubber tube like this and if we just keep the gas jar is also a somewhat heavy jar, not very heavy but somewhat heavy. If you keep it on the rubber tube will be pressed. So, the gas cannot enter into the gas jar easily. So, when we have the beehive shelf, like I said, there is a hole opening on the side. Through that, we can easily direct the rubber tube so that the gas can flow without any hindrance, any disturbance, or it will not get stuck. It will flow easily. So, that is the use of a beehive shelf. So, there I will write that also. Beehive shelf is useful in directing the gas from the rubber tube into the gas jar easily and also easy to stand the gas jar. And another thing you have to remember, the gas jar has to be filled completely with water. Make sure there are no gas or air bubbles So we have to make sure it's only completely filled with water. So usually what we can do is, when I do it in the lab, you can observe that we need to fill the gas jar with water, and also inside the trough we need to fill it with water and make sure there are no gas bubbles. If we want, you can also use a watch glass to cover the mouth so that nothing goes in, and we can insert it and set it up without any problem. So you have to be sure with the setup, students, and you should know the practical considerations also. So students, this is how we prepare the setup, And here you can also see that when we connect the thistle funnel, as I told you all before, it has to reach to the bottom so that directly the acid comes and falls on the zinc granules. The reaction is faster, and also we make sure that the gas does not escape from the setup. So thereafter, what do? We have the second glass tube, that is the delivery tube, slightly higher above the position. So the glass delivery tube is attached at a higher position. So there, of course, it has to be at a higher position so that the gas, hydrogen gas that goes up will enter into the tube. And also here again, as I told you all, we make sure that the gas does not escape from the apparatus. Instead, it is directed into the delivery tube and thereafter into the gas jar. So then we use the beehive shelf that is useful in directing the gas from the rubber tube into the gas jar easily. I explained that process also to you all. It's easy to set the gas jar and everything. Otherwise, we will have to be holding it or we need to clamp it. Than that, this is easier. And the gas jar has to be filled completely with water, and we make sure that there are no gas bubbles or air bubbles inside it. So that is how we carry out the activity. So I am sure students you have understood the procedure properly. I will go to the next slide. There again I will discuss the procedure and then I will carry out the activity in the lab. So the method. Arrange the apparatus as shown in the figure above, that was there in the previous slide. So you have to arrange that setup and you should be able to identify all the glasswares and all the materials that we use there. Then collect several samples of hydrogen gas. Since a gas jar requires a large amount of gas, you can use about 5 test tubes. So instead of a gas jar, we can also use test tubes. Or what we can do is we can use the gas jar to observe how the downward displacement of water takes place, and then we can collect some gas into test tubes as well. So thereafter, close well the mouth of the test tubes filled with the gas and take it out of water. Introduce a lighted ether into this test tube. This is in order to identify the hydrogen gas. So here you can remember students, I explained this to you all before also. So we have the gas jar. So here we have the gas jar. So this gas jar has to be filled with water. So initially gas jar has to be filled with water. Then it is, I am only showing the necessary parts. I am not drawing all the setup, the whole setup. So here what happens? Hydrogen is collected here and water is displaced down. Why? Because density of hydrogen gas is less than that of water. So because of that, what is the name given to this process, students? I told you all, water is displaced down. Downward displacement of water. Downward displacement of water. So now you know the setup, how you should set up the apparatus to collect hydrogen gas, and you know all the practical considerations. Then you know the method, you know hydrogen gas will be collected at the top and water will be displaced down. Why we use the beehive shelf, all that is familiar to you all. So as explained or instructed in the method, we can use a gas jar or we can use about 5 test tubes, or like I told you all, we can collect it in the gas jar and in a test tube. And then again, this particular activity using a lighter decal is to identify that it is hydrogen gas. So I'm sure you all can understand the procedure. We will go to the lab and do this activity now. So I'm going to do the activity where we collect hydrogen gas, preparation of hydrogen gas. So to do that, we need reactants. And you all know the reactions. When a metal reacts with an acid, usually hydrogen gas is evolved. So here I have magnesium metal. Magnesium is being taken as the metal. And for the reaction, you can use either dilute hydrochloric acid or dilute sulfuric acid. So here I have dilute sulfuric acid. You can also use dilute hydrochloric acid. So those two are the reactants, magnesium and dilute sulfuric acid. Then here the materials that I need all are here. You can see the conical flask. So we will be taking the magnesium into the conical flask. Then I have here a rubber stopper. There is a rubber stopper with a thistle funnel attached to it, and thereafter you can see the glass tube with the rubber tube that is known as the delivery tube. Through this only the gas will be transferred or delivered into the other side where it gets collected inside the gas jar. We need to connect this to the conical flask. So when we connect it, you all can see students, the thistle funnel has to go right up to the bottom of the conical flask. The reason is one thing, the hydrochloric acid will be transferred through the thistle funnel. It will go right down and fall on the top of the magnesium. Then magnesium can start reacting. At the same time, the thistle funnel will be dipped in hydrochloric acid so that the gas that is evolving from the reaction will not escape through this thistle funnel, because there's no way it can go through this. But the other tube, the delivery tube, you can see is higher in level. So the gas, you all know, normally hydrogen is very lighter than air. So it usually rises up. So when it rises up, it can enter through the delivery tube and it can be transferred to the other side through this tube. At the same time, you all are familiar with this. This is the beehive shelf. So beehive shelf, you all can see there is an opening there. Through this, we will be sending the rubber tube. And here again, there is another opening. I will be placing the gas jar on top of that. So through the delivery tube, the gas will come. It will enter into the beehive shelf and then it will be transferred into the gas jar. So this is the gas jar. Normally what we need to do is we need to have it inverted, and here the method that we are going to use in order to collect the gas is known as the downward displacement of water. So to do that, what we need to do is we need to fill water completely into this gas jar and it has to be inverted over the beehive shelf. So we have to make sure that there are no air bubbles inside it, so that we can collect only the pure hydrogen gas. So to start the activity, what I will do is I will fill this gas jar with water and then I will invert it. And another thing, we have this glass. So normally when we collect the gas, in order to take it out without letting the gas to escape, what we can do is we can use this glass, we can cover it like this and we can take it out of water. At the same time, even if we want to fill water outside, then also I can cover it with this glass and I can invert it and send it into the trough. This is the trough containing water. And thereafter, I have a test tube that I'll be using in order to collect the gas again. That method is known as the downward displacement of air. I will explain that again as well. So I'm going to fill the gas jar. As I told you all students, I have to make sure that there is no air inside the gas jar. So now here you can see it's filled completely with water. When we invert it, again you can see there are no gas bubbles inside. So then of course I can place the beehive shelf inside water. We have to make sure that the inlet, this opening is facing towards this side. So it will be easy for me to insert the delivery tube there, the rubber tube. So then I have to place the gas jar on top of the beehive shelf. So now we need to take the reactants. So first what I will do is I will put some pieces of magnesium strip there. So then when I fix it here, now as I told you all students, the thistle funnel goes right down, and here in all these places you can see there is wax. That is to prevent the gas from escaping out. So everything has been sealed, and this also has to be connected tightly. And then we need to insert this. We need to insert this into the beehive shelf. So I will insert it this way. So then I will have to add the sulfuric acid, dilute sulfuric acid. So when I add dilute sulfuric acid, you will be able to see the reaction. You all are familiar with this reaction. Reaction of magnesium with sulfuric acid. When the gas starts to evolve, it will be collected here. You can see the gas bubbles coming. So you can see the reaction starting, and now you can see through the delivery tube the gas is coming up. You can see the water level going down. So that is why we call it downward displacement of water. Now this is possible because hydrogen is lighter than water or less denser than water. So water will be pushed down while hydrogen goes up, and it gets collected over the water level. So downward displacement of water. You can see the reaction taking place. And here also students, we have to remember hydrogen is slightly soluble in water. So because of that, there isn't much hydrogen wasted there. Only a small amount will dissolve in water. If we want, before sending hydrogen into the gas jar, we can saturate the water with hydrogen, and thereafter we can collect the hydrogen gas. So I'll need to add a little bit more magnesium strips. And a little bit more sulfuric acid. So here students, I have collected only a small amount of hydrogen gas into this, but we can collect any amount that we need. We can even come up to this level. So we can collect any volume of hydrogen as we need. So now what I am going to do is, I am going to use the second method. I told you all the downward displacement of air. Again, you all know students, the hydrogen gas is less denser than air. So what will happen? Now in this test tube there is air. If I invert it, and instead of the gas jar, if we have this test tube inverted, and if I pass the delivery tube into the gas jar. Then what will happen? The hydrogen gas will go up, it will push the air down, so air will flow downwards and the hydrogen gas will get collected inside the test tube. So that is the method I am going to use next, and with that we will do the test for the identification of hydrogen gas. You all know the test. What do we need to do? We need to insert a burning splinter. Then you will get the observation. So now I am going to remove and I'll add a few more pieces of magnesium. If I add dilute sulfuric acid a little bit more. So here, as I told you all students, we will need to test for the identification of hydrogen gas. So as you can see, when the magnesium reacts, now the reaction is completed. So there will be hydrogen gas here. What I need to do is I need to take the test tube with hydrogen gas and insert a burning splinter. So when we insert the burning splinter, it burns with a pop sound. So that confirms the gas that we collected is hydrogen gas. So from these activity, students, you all know how we need to have the setup to collect hydrogen gas by the downward displacement of water. So for that, all the materials that are needed, the trough containing water, beehive shelf, on that we need to have the gas jar completely filled with water, and we will be collecting the gas with the downward displacement of water. And as I told you all before, there is wax around all these holes so that the gas does not escape from the setup. And also we have the conical flask, the long thistle funnel, and the short glass tube that is used as a delivery tube. So with that, you all know how we need to collect the hydrogen gas. And finally, we saw the hydrogen gas being collected by the downward displacement of air, and also how we need to test for the confirmation that it is hydrogen gas. So that is to identify hydrogen gas. When we insert a burning splinter, it burns with a pop sound. So that is the activity of collecting and identifying hydrogen gas. Okay, students. So did you all observe how we set up the apparatus to collect hydrogen gas properly? I am sure you all did. And then you saw how hydrogen gas was collected by the downward displacement of water. So during this, what were the observations you all saw? You saw the reaction of hydrochloric acid with zinc and the evolving liberation of gas bubbles that was visible, but you couldn't see the gas being delivered from the conical flask to the gas jar, but thereafter you were able to see the gas bubbles going up through the water in the gas jar. And then you saw the gas collecting above water and the water level being pushed down. That was one observation. So you were able to observe the downward displacement of water and the collection of hydrogen gas at the top. Then what did we do? I used the lighted eagle. What happened when I inserted the lighted eagle into the test tube containing hydrogen gas? What did you all hear? You heard the pop sound. So the lighted eagle, or what we call as the lighted splinter, burns off with a pop sound. So that observation is to identify that the gas that was collected is hydrogen. You are familiar with this also, students. Before also you have learned this. We use different methods or different activities to identify different gases. So to identify hydrogen gas, we use a lighted splinter, a burning splinter, or a nickel with a flame. When you insert that into a test tube containing hydrogen, it burns off with a pop sound. Very important. It burns with a pop sound. So those were the observations. So here we can say hydrogen gas was collected by the downward displacement of water when zinc reacted with dilute hydrochloric acid. Then we saw the burning splinter. Or the eagle burns with a pop, very important, pop sound when inserted into the test tube with the gas. So those were the observations. And from that, what can we conclude? So here, hydrogen gas produced, or you can say liberated, during the reaction between zinc and dilute HCl is collected by the downward displacement of water That is one conclusion. You can collect it using the reaction between zinc and HCl, and also the process is downward displacement of water, and by doing the next activity we confirm that it is hydrogen gas. It is confirmed to be hydrogen gas using a burning splinter. So those are the observations, the downward displacement of water and the collecting of hydrogen gas when the zinc reacts with hydrochloric acid, and also the burning splinter burning with a pop sound. That is very important, the test to identify hydrogen. So from that we confirm the process of preparing and collecting hydrogen gas, and also we confirm that it is hydrogen gas using the burning splinter. You have to remember these, students. So I am sure you all can understand this procedure as well as the observations because it was very clear to you all during the activity. With that, I will move on to the next slide. So here, this method of collecting a gas is known as the downward displacement of water because when the gas enters the gas jar, the water in it is pushed downward or pushed down. So this is important. I have already explained this to you all. It is downward displacement of water. The gas coming from the delivery tube can also be collected by keeping a gas jar as shown in the figure below. So the gas coming from the delivery tube can be collected by keeping a gas jar as shown in the figure below. This is the figure. Now you can remember, students, hydrogen is lighter than atmospheric air. That is, the density of hydrogen is less than that of air. So what we can do is, this is the delivery tube. Delivery tube. So through that we pass hydrogen. What we can do is, we can allow it to go into a gas jar containing atmospheric air. So this is a gas jar. No water, we don't fill it with water. If we don't fill it with water, you all know there is air inside it. But hydrogen is less dense than air. So because of that, hydrogen will go up, H2 will go up and air will come down. So this is going to be the downward displacement of air. Hydrogen goes up, air comes down. Here you can see the downward arrow shows the atmospheric air. Hydrogen is going up. So hydrogen will be collected inside the gas jar. But unlike in the activity where we use the downward displacement of water, here of course you cannot see the downward displacement of air. Why? Because air is colorless, hydrogen is also colorless. So it's difficult to observe it, see it, but you can collect it using this method. You have to remember that as well. So since the density of hydrogen gas is less than that of normal air. So here we have discussed that before. Density of hydrogen gas is less than that of normal air. It moves up the jar. Then the atmospheric air in the jar gets pushed down and removed. This method of collecting a gas is called downward displacement of air. So two methods, downward displacement of water, downward displacement of air. Both methods can be used to collect hydrogen gas in the laboratory. But only thing, when you have downward displacement of water, the gas jar has to be kept on a beehive shelf placed inside the trough containing water. But if it is downward displacement of air, directly we can pass the hydrogen gas into a gas jar containing atmospheric air. So the air will be pushed out, hydrogen will be collected there. Is that clear to you all? So with that, students, I will move on to the next slide where we discuss the uses of hydrogen gas. So uses of hydrogen. I have actually shown it in a diagrammatic manner. The pictures, the diagrams are given to you. The first one, production or manufacture of margarine. Hydrogen is used in the manufacture of margarine. So here, one use is manufacture of margarine. So that is the first one. Then we know it is a combustible gas. So because of that, it can be used as a fuel for rockets. So the second one is used as fuel for rockets. Then you can see here, this is ammonia. ammonia gas, you're familiar with that, NH3. And from ammonia, we can prepare nitrogen fertilizers like urea. So to produce ammonia, we react hydrogen gas with nitrogen gas. So production of ammonia, gas by the reaction of hydrogen with nitrogen gas, and also this is used to produce fertilizers like urea. So that is another use of hydrogen gas. Then here this is a reaction. You don't have to go into detail there, but you can see this particular compound, actually you're familiar with this. This is ethene molecule and this is ethane molecule. Don't worry much about their chemical formula because you will be discussing these hydrocarbons in the next grade. So these are organic compounds. You're familiar with that. When we say organic compounds, compounds that have carbon. So exceptions are carbon dioxide, carbon monoxide, those are the oxides, carbonates and bicarbonates. Although they contain carbon, they are not organic. They are inorganic compounds. So when you have organic compounds, this particular reaction is known as the reduction. So hydrogen, here you can see hydrogen is used to reduce organic compounds, or to convert one organic compound into another organic compound, we sometimes need to use hydrogen. So that is another use of hydrogen. Used in the reduction reactions of organic compounds. So those are the uses of hydrogen gas. So uses of hydrogen: manufacture of margarine, used as a fuel for rockets, then production of ammonia gas by the reaction of hydrogen with nitrogen gas, and also that is used to produce fertilizers like urea. Here students, this is ammonia, AMMONIA, ammonia gas. Then it is used in the reduction reactions of organic compounds. So those are the uses of hydrogen gas. With that students, I will move on to the next slide. So here we have an assignment. Inquire into the substances used to fly a small balloon. Collect the necessary materials and fly several balloons under the guidance of the teacher. Look into the reactions happening. So this is something that is already familiar to you all students. Now we saw a few reactions that are used to prepare hydrogen gas in the laboratory. You all can remember that. Metals, when they react with dilute acids, one of the products is hydrogen gas. So we said either zinc or magnesium can be reacted with dilute sulfuric acid or dilute hydrochloric acid to produce hydrogen gas. So that is a type of reaction, a single displacement reaction between a metal and dilute acid to prepare hydrogen gas. So if we need to fly a small balloon, how can we do this activity? We can take a test tube or even a conical flask. maybe a conical flask like we did in the activity before. And into that, we can put zinc granules. You can put zinc granules, that is here, or you can put pieces of magnesium. And to that, what can you do? You can add dilute hydrochloric acid, or you can use dilute sulfuric acid. Then what do? As you add the acid, you know these are somewhat fast reactions. So they will start reacting quickly. What we can do is we can connect a balloon. Once it starts reacting, if you connect a normal balloon, the balloon will get inflated. Inflated by what? Hydrogen gas. So you can get the balloon to be inflated, you can tie it, you can remove that, then you can tie it, at the same time you can fix another balloon. So until the hydrogen gas is being evolved, you can fill many small balloons. So they say fly a small balloon. And once you tie it and allow it, just release it, you can observe that the balloon goes up. You know the reason. Why? Because hydrogen is less dense than air. So because of that, it will go up. So that is how you can fly a small balloon. And here you need to know the reactions. I am sure you can remember that we have been writing these reactions over and over again. What is the reaction? If it is with zinc, HCl, you get ZnCl2 plus H2 gas. If it is with magnesium, I'll write it with sulfuric acid, H2SO4, you will get MgSO4 and H2. You need to balance the equation, zinc plus HCl, that has to be balanced by putting a 2 there. But this reaction, of course, is already balanced. So I have written one equation for each. You can use magnesium here, so you will get magnesium chloride there. If you use zinc here, you will get zinc sulfate there. So both reactions are possible, and you know these are single displacement reactions. Single displacement reactions. And you know, students, we have both magnesium and zinc above hydrogen in the activity series. That is why both the metals are able to displace hydrogen from the solution. I am sure you all can remember all these. Now, this is something that we can do in the lab. So, like this, if you want to do the same activity, if you want to fly small balloons in your household, instead of this zinc granule or the metal, and as well as the dilute acid solution, you can find substances at home. Can you all think of something like that? A metal that we use at home. You can get hold of aluminium foil. An acid. You can use vinegar. Vinegar, you all know, is acetic acid. So instead of this, you can say in the household. Again, you can have, so here of course, you will not have a conical flask or a test tube. Then what can we use? We can use a glass bottle. So you can take a glass bottle like that, and into that you can put aluminium foil pieces, and to that you can add vinegar. Vinegar is acetic acid. Acetic acid is CH3COOH. CH3COOH, that is acetic acid that is present in vinegar. So we have the acid that is a dilute acid and we have aluminium foil. So metal with an acid will evolve hydrogen gas. Again we can fix the balloon here and get it inflated. Can fill hydrogen gas into the balloon. So is that clear, students? We can do it in the lab. A similar reaction can be done in the house also, at home also you can try that. So here of course you have aluminium as the metal and acetic acid, that is vinegar. So here you will get the salt plus hydrogen gas. This is what we need. So again a metal and acid. A metal and acid. Vinegar is acid. So that is also a single displacement reaction. They have told you all to consider the reactions as well. Is this clear to you all? So a similar setup here, instead of the test tube we use the glass bottle. Glass bottle. That is also okay. So either in the lab or at home you can prepare hydrogen gas and you can fill small balloons and you can fly small balloons. So with that, students, I am going to end this chapter where we discuss physical and chemical properties of hydrogen gas. Then I explained in detail how you set up the apparatus to collect hydrogen gas in the lab, all the considerations, and you saw how we can collect hydrogen gas and we test and confirm that it is hydrogen gas using a burning splinter, and it burns off with a pop sound. We confirm that it is hydrogen gas, and then we discuss the uses of hydrogen gas and finally this activity. So with that I will end this chapter, and in the next chapter I will discuss the properties, preparation and uses of oxygen gas.